Good morning dear students. Today we will discuss study about class 11th chapter 1 sets. Initially we will discuss about its definition, examples, basics, and we will go through then its exercise questions. Okay, we will start by definition of set. What do you mean by a set? A set is a well-defined collection of objects. Here you see collection of objects. We simply see a collection of objects. In mathematical term we called these as sets. For example, the states of India, the vowels in English alphabet like A, I, U. This is a collection, and in mathematical term we call it as a set. Here also one condition applied. It should be universal, means well defined. Like the states of India, for everyone the states of India are same. It is a well defined collection of objects. In objects all things are covered, like numbers, states, things, everything. The vowels of English alphabet, these are universal. So what does it mean? A set must be well defined and a collection of objects. Suppose, let's say I ask a student your favorite movies, and I ask other students your favorite movies. Both have different choices. That can't make a set. That should be universal, well defined. So these are the examples. Now we will discuss other examples of in mathematics. The set of all natural numbers. We represent these by n. The set of all rational numbers. We represent it by q. The set of all integers. We represent it by z. The set of all real numbers, r. Next, the set of all positive integers. Integers z or positive. Here it takes a sign of plus. The set of all negative real number and negative. So here are the examples of set. Here called it as a collection of objects. Means in objects everything is covered, like numbers, other things, all are covered. So these are the examples. Now we will discuss some important facts about this set. This is not need to be remembered, but I just gave you idea of how it works. The theory of set was developed by a German scientist George Cantor in 1850. Okay, this is the first fact about set. Second fact, the study of set is mandatory for understanding concepts like we will see geometry, probability, and sequence and series. Probability. sequence and series and relation and function. We have seen definition and examples of set. Now we move on to next topic, representation of set. How a set is represented. There are two methods of representing a set. First, roster form, or here we can say tabular form also. Second, set builder form. Now we will take example to understand this. The set of odd numbers less than 10. First we will write in roster form, then second set builder form. Here roster form, how it is represented, we will see. You make brackets. Now we know odd numbers less than 10. So 1, 3, 5, 7, these are, and 9. These are odd numbers less than 10. 1, 3, 5, 7, and 9. So this is representation of a set in roster form. Now we will see in set builder form. Here we will take x as a symbol. X is odd number, but where x is less than 10. So it simply means this 1, 3, 5, 7, 9. But it is a representation in two ways. We will now discuss some questions based on representation of sets. First, write the solution set of an equation x square plus x minus 2 equals 0 in roster form. We have to write this in roster form. First, we have to solve the equation through prime factorization method. Here you see it is a quadratic equation. If someone don't know, I will show you. X square plus x minus 2 equal to 0. Multiply these to get the middle term, minus 2x square. Now factorization to get this plus 1x. Here we need 2x and x. Here the sign minus and here plus. So it needs to be minus and this needs to be plus. So add them and we will get this middle term. Now equation can be written as x square take common x. Here we will take common minus 1. What we will get? X minus 1 and x plus 2. This is prime factorization method. And you will get this. Now set A in roster form. This is our solution. Now second, we move on to second question. Write the set A 1, 4, 9, 16 in set builder form up to infinity. This is up to infinity. Means whole natural numbers are included. These are, you can see these are the squares of all natural numbers. 1 square 1, 2 square 4, 3 square 9, 4 square 16 up to infinity in set builder form. Now we will have to represent it in a set builder form. This is set builder form. We will represent this as x equal to n square, means all natural numbers are included. The square of all natural numbers are given. X equal to n square, where x belongs to natural number. So these are the, we will discuss types of set. We have some types of set. We will discuss sequentially. Initially we will start from empty set. What do you mean by empty set? We can call it also null set. Means we will understand this by example. So see x, where x is a natural number, where x is greater than 1 and less than 2. Now we will make a set A. Here it is written x is natural number and x is greater than 1 and less than 2. So there is no natural number lies between 1 and 2. We will know that. So this set will be empty. This is representation of an empty set. Or we can write it at 5. So it means it has no element. It doesn't contain any element. This is called empty set. Doesn't contain any elements. Now we will move on to next. Second, finite and infinite set. What does it mean? This simply means, understand that finite is fixed set of numbers and infinite means infinite set of numbers. We will understand this by example also. Vowels in English alphabet. We can make a set like A, E, I, O, U. So this is called a finite set because in this there are finite number of elements. Here set of integers means minus infinity to 0 and 1 to plus infinity. So this is an infinite set, example of an infinite set. Means infinite number of elements. Now we will move on to next type of set, which is called a singleton set. Singleton set, it simply says which contain one element in a set. Which contain single element. Like for example, x is a prime number and x is less than 3. So we know the prime numbers 2, 3, 5, 7, but here x is less than 3. So how a set is introduced? A is equal to 2. this is our set. So it contains only one element. So it is called as singleton set. Now, next we will move on last and important type of set, which is called equal and equivalent set. So here this is example. First, there are three sets given: A, 1 and 2, B, X. The equation is given quadratic equation x square minus 3x plus 2 equal to 0. C, x belongs to natural number and x is greater than 1 and less than equal to 3. Now we will have to find elements. In set A we have already elements 1 and 2. In B we will have to find it. So here by prime factorization method we get 1 and 2 elements of x, and we will move to the third set C, which belongs to natural number and less than 3, greater than 1 and less than 3. So it will be 2 and 3. It will be 2 and 3. So we will get elements of all three sets: A, 1, 2, B, 1, 2 and C, 2, 3. Now we will understand what does it mean by equal set and equivalent set. Here A equals to B. It means number of elements and the elements are exactly equal. Here A, B and C, but not equal to 2, 3. A is equal to B but not equal to C. So A and B are equal sets, and A, B and C are equivalent sets. How? Because they contain same number of elements. In equivalent set we will see number of elements, and in equal set we will see the exactly elements are same or not. A and B have same elements, so 1 and 2, 1 and 2, so they are equal sets. But 2 and 3, this is not equal set. In equivalent set, what we see, the number of elements are equal or not. So A, B and C contain equal number of elements. Set A has 2 elements, set B has 2 elements, and set C has also 2 elements. So A, B and C are equivalent sets, but A and B are equal sets, not C. Thank you.